All right, let's review what we did for this week. We're going to review about the trigonometric functions. One thing I want to review, remember in your geometry class, once again, you guys learned SOHCAHTOA. And that's how you guys find out that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. I'm using the Greek letter theta, so I'm sine of theta, cosine of theta, tangent of theta. But then this week, I also introduced cosecant of theta is hypotenuse over opposite, secant of theta is hypotenuse over adjacent, and cotangent of theta is adjacent over opposite. Make sure you understand this table. If you need to copy it down, write it down, however you need to do it. I just want you guys to emphasize that SOHCAHTOA give you your sine, cosine, and tangent. Now, cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. And cotangent is the reciprocal of tangent. Trying to have you guys be able to write it down, from your memory if you ever need to. If you look at cotangent and tangent, it kind of looks like each other backwards. Like cotangent, it kind of looks like tangent backwards. Right, a few, a couple letters that change, but kind of looks like tangent, and they are reciprocal of each other. The same thing with cosine and secant. Right, secant looks kind of like cosine backwards, and yes, secant is the reciprocal of cosine. Now, cosecant and sine, they don't quite look like each other, but they are the reciprocal of each other as well. Okay, so having that said, let's take a look at our work. Find the value of each trigonometric function. We're supposed to find the cotangent of theta. Now, when it comes to cotangent, I know it's adjacent over opposite. We just covered that. Now, let's see in blue what I have. I have that cosine of theta is 4 over 5. All right, so let me draw my triangle. I'm going to draw my theta here. I know cosine is adjacent over hypotenuse, so that means that adjacent is 4 and the hypotenuse is 5. For cotangent, I need adjacent and opposite. The opposite, I don't know what it is. At this moment, I don't know, so I'm going to call it x. I know how to use Pythagorean theorem. I know that my hypotenuse in this case is 5. So that's what I'm going to leave by itself. I'm going to write x squared plus 4 squared equals 5 squared. I have that x squared plus 16 equals 25. Let me subtract 16 from each side. X squared equals 9. So x must be the square root of 9, better known as 3. So I know that side. For cotangent of theta, I needed adjacent over opposite. So I'm just going to write 4 over 3. When you type it, you go 4 over 3. Let's take a look at question number 2. I need tangent of theta. Now, tangent of theta, I know tangent is opposite over adjacent. Let's see what I have. I know that cosecant of theta is radical 13 over 3. Now, cosecant from the table that we know, I know is hypotenuse over opposite. So let me draw my triangle. I'm going to draw my right triangle. One corner I'm going to call theta. And my hypotenuse is radical 13th. The opposite is 3. Remember, opposite is the side that is far away from the theta. Okay, so I need adjacent and opposite. So I need to solve for x. I don't know the adjacent side. So I'm just going to say that x squared plus 3 squared is equal to square root of 13 squared. Remember, the hypotenuse in this case is radical 13. So I have that x squared plus 9 is equal to 13. Let me subtract the 9. X squared is equal to 4. So that means that x must be the square root of 4, better known as 2. I need to do, for tangent, I need to do opposite over adjacent. So I'm just going to write this as 3 over 2. I'm going to type this as 3 over 2. Looking at question number 23, I need to find sine. And I know sine is opposite over hypotenuse. Let's take a look at what I have. Cosecant of theta. I know cosecant is hypotenuse over opposite. I'm not going to draw my triangle because I have what I need. Actually, let me write it. Here's my theta. I have the hypotenuse is 5. I have the opposite is 3. For sine, I need to do opposite over hypotenuse. So I'm just going to write 3 over 5. I have what I need. When I type this, I'm just going to go 3 over 5. Now let's take a look at number 24. I need to find the secant. And I know secant is hypotenuse over adjacent. Let's see what I have. I know cosine is opposite over, cosine is adjacent over hypotenuse. I guess you guys can see I don't need to write the triangle. If I have that cosine of theta is 3 over 5, I'm going to say the secant is 5 over 3. And I'm going to type this as 5 over 3. Now let's take a look at question number 25. Use the given point on the terminal side of angle theta to find the value of the trigonometric function indicated. Okay, so I am going to create a triangle. From the point that I'm given, that terminal point, I'm going to connect it with my x-axis. That way I have a right triangle. If you notice, I have this triangle. Now, the corner that is at the vertex, I'm going to call that theta. So that means that's my theta. My coordinates, I have an x and a y value. The x value is the side that touches the x-axis. So this side is 2. So that means this triangle is 2. The y is the side that goes up and down. So it's 2 radical 3. That means this side is 2 radical 3. All right, so let's see what I need. I need secant. Secant I know is hypotenuse over adjacent. I don't have my hypotenuse, so I need to solve for the hypotenuse. Let me call it x for right now. The way I'm going to solve for hypotenuse, I'm just going to go 2 squared plus 2 radical 3 squared is equal to x squared. I know 2 squared is 4. Now 2 radical 3 squared, let me square each part. If I was to square 2 squared, if I would get 2 squared, that gives me a 4. If I was to square the radical, that gives me 3. Combine, give me 12. I multiplied it. So I did the outside number first, so 2 squared. I did the radical by itself. That gave me 3. Multiplied equals 12. So I have that 4 plus 12 equals x squared. So I have that 16 is equal to x squared. That means that x is the square root of 16, better known as 4. So for secant, I need hypotenuse over adjacent. I'm just going to write this as 4 over 2. I'm going to write it up here. 4 over 2, better known as 2. Sometimes my fractions simplify to a whole number. All right, let's take a look at number 26. I need to find out the tangent. And I know tangent is opposite over adjacent. Let's see what I have. From the point that I'm given, I'm going to connect it to the x-axis. That corner is theta. So if I was to make my triangle bigger, this is what I have. That 17 is the side that is on the x-axis. So this is 17. The 2 is the side that goes up and down. It looks like the y-axis. All right, so it seems like I don't need to solve for hypotenuse. I have what I need. I need to do opposite over adjacent. So opposite over adjacent, I'm just going to go 2 over 17. I will type that as 2 over 17. Let's take a look at number 27. I'm going to connect, well, first of all, cosecant. Cosecant I know is hypotenuse over opposite. So let's see what I have. My point, I'm going to connect it straight to the x-axis to make my triangle. The corner is the origin, that's my theta. So when I see this is what I have. Remember my terminal point, my x and my y value. The x is the side that is on the x-axis. The y value is the side that goes on, up and down. It goes parallel to the y-axis. So I have that this side is radical 19 and this side is negative 9. For cosecant, I need to know my hypotenuse. I don't know the hypotenuse, so I need to solve for the hypotenuse. So I'm just going to write that square root of 19 squared plus negative 9 squared is equal to x squared. So I have that 19 plus 81 is equal to x squared. I know 19 plus 81 is 100. So 100 is equal to x squared. So x must be the square root of 100, better known as 10. Okay, so now I have the hypotenuse. And I have to go hypotenuse over hypotenuse over opposite. So I have to go 10 over negative 9. The way I simplify this, the negative sign, at least let me bring it to the front. My fraction 10 over 9, I'm just going to leave it as 10 over 9. The way I will type this, I will type the negative at the front and then 10 over 9. Now let's take a look at number 28. Sine. Remember from the table, I need opposite over hypotenuse. Let's see what I have. From the terminal point, I want to connect it to the x-axis to create a right triangle. The corner at the origin, that's my theta. So if I was to zoom in, that's what I have. My x and my y value, the x value is on the x-axis. So this side is negative 9. The y value is the side that goes parallel to the y-axis. So that means this is negative 9. This is negative radical 19. I need to solve for my hypotenuse because I need the hypotenuse for my answer. So I have that negative 9 squared plus the negative radical 19 squared is equal to x squared. Negative 9 times negative 9, that's 81. Radical 19, well, negative, I know negative times negative is positive. Radical 19 times radical 19 is 19. 100 is equal to x squared. So that means that x must be square root of 100, which is 10. So now I know my hypotenuse is 10. I need opposite over hypotenuse. Remember, opposite is the side that is far away from the theta. So negative radical 19 over 10. Bring the negative to the front of the fraction. I'm going to go radical 19 over 10. It's okay to have a radical on top. So the way we're going to type this, we're going to go the negative radical 19 over 10. All right, so now let's move into question number 29. The reference angle. The reference angle is having the corner, having the point where this thing ended. Let me do this in green. What's the angle that is closest to the x-axis? That's what I want to know. What's the angle? Reference angle, we always write this as a positive. The reference angle is always written as a positive. Now, on my angle, I have a negative sometimes. Just the negative just tells me that I was going clockwise. The negative on the angle is just for me to know which way I was going. Was I going clockwise or counterclockwise? In this case, clockwise. We talked about that we start here. So far from an axis to another axis, that's 90 so far. That's 90 right there. That's 90 there. That's another 90. That's another 90. That's another 90. That's another 90. So if I was to add how many 90s I have, let's see, I have 1, 2, 3, 4, 5, 6, 7. 90 times 7 is 630. So far I have 630. I was told to begin with that I had gone 650. So remember, in green so far it is 630. Shouldn't I call this 20? Because the whole thing so far in green, the 90s, I counted the 90s, that was 630. It said I went 650, so shouldn't that mean that there's 20 more? Now, I know this whole thing is 90. Part of it is 20. Shouldn't I call this 70 since the whole thing is 90? I just figure out that the angle that I was looking for is 70. Let's take a look at number 30. I'm looking for how much is this angle. Remember, right where the arrow ends, what's the closest distance to the x-axis? Okay, let's take a look. I know this is 90. The whole angle was 130. Shouldn't I just say that this remaining part is 40? Remember, because the whole arc was 130. So that's 40. Now, I know this whole thing is 90. Part of it is 40. I'm looking how big is the other part. Shouldn't the other part be 50 since the whole thing is 90? I just found out that the angle what I was looking for is 50. Now let's take a look at number 31. I'm going to start here. That's 90. Right, from a vertex to another vertex. That's another 90. 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 And that's another 90. So far, let's see, I have 1, 2, 3, 4, 5, 6, 7 90s. I know 6 times, and 7 times 90 is 630. So shouldn't I know that this angle right here it is 65? Remember, the 90s that I counted were 630. So to complete the 695, that should be 65. I'm asking, how big is this angle in green? I know this whole thing is 90. 65 is part of it. Shouldn't I call the other part 25? Since the whole thing is 90, right? 90 minus 65 gave me 25. That means the angle I was looking for is 25. Let's take a look at question number 32. The angle that I'm looking for, right where the arrow ends, I'm looking for the closest distance to the x-axis. All right, so let's figure this out. If I was to start here, that's 90 right there. That's another 90. 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 So I have, let's see how many 90s I have. 1, 2, 3, 4, 5, 6, 7. 90 times 7 is 630. So shouldn't I know this angle right here is 50? Because remember, the whole thing is 680. So far, I have 630. When I say so far, it is from the beginning all the way to here. So that's how I know that part is 50. All right, so I'm asking, I know this whole thing right here is 90. I'm asking if from the whole thing is 90, part of it is 50, how big is the other part? In this case, 40. All right, that was simple. Let's take a look at question number 33. Now we want to know how big is this whole angle. Okay, so it's number 33. Find the measure of each angle. Starting from here, that's 90, that's 90, that's 90, that's 90 so far. That's another 90, that's 90, that's 90, and that's 90. Let's see how many 90s I have. I have 1, 2, 3, 4, 5, 6, 7, 8. Okay. 90 times 8, that's 720. So that's 720 so far. 720. Let me add this 55 because I still have this. 720 plus 55, that will give me 775 because I was going counterclockwise, my angle is going to be positive. Now, when I go clockwise, the angle is negative. In this case, the angle is positive because I was going counterclockwise. All right, let's take a look at number 34. I start here. So far, this is 90. I know this is 55. So the whole thing is 90 plus 55. That will give me 145. Now, when I see I was going, my angle, I was going clockwise. That means my angle is a negative 145. The sign at the beginning is just direction, whether I was going clockwise or counterclockwise. All right, let's take a look at number 35. So I start here. It seems it's like almost the whole circle, a little less. So just from the bat, I'm expecting a number just a little bit smaller than 360. Okay, so I go this way is 90. That's another 90. That's another 90. So far I have, right, 90 times 3 is 270 plus 85. I know this right here, it is 85. 270 plus 85, 355. I was going clockwise, so it's negative 355. Take a look at number 36. I start here. So far that's 90. So far that's 90. So that's 180. Now here, I have a 140 there. So I want you guys to see one thing. Here in blue is what I need. Okay, so once again, let me start. I had this as a 90. This right here is 90. I don't know how much is the other part. However, in green, so far this is 90. I'm going to say this part right here is 50. Right, because 90 plus 50 gives me 140. Now when I look here, my eyesight is right here. I know this whole angle is 90. Part of it is 50. I'm wondering how much is this part? The whole thing is 90. Part of it is 50. Shouldn't I just call that 40? My angle, I was going counterclockwise, so that means it's positive 40. I mean, not positive 40. This is 40, but I had to add 90 plus 90 plus 40. That's 220. All right, so now let's take a look at the last four examples, 37 through 40. Convert each degree measure into radians and each radian measured into degrees. We mentioned this week that 360 degrees is equal to 2 pi radians. It's another measurement how we measure a circle. Circle can be measured in many ways. Radians, degrees, gradients. There's another gradients as well. There's still other measurements. So 360 degrees is equal to 2 pi radians. Okay, so now here we're asked how much is 2 pi? Obviously, we're given the information in pi, so we have degrees. We're looking for degrees. I know 360 degrees is 2 pi. So here the question is how much is 2 pi? I'm just going to say, well, 360 degrees. All right, that was simple. It was given there, basically. Now, looking at number 38, I start with a negative pi over 4. My measurement's given to me in pi, so that measurement's given to me in radians. So I'm going to multiply this because I need to give it in degrees. I'm going to have 360 over 2 pi. Since I want the pi's to cancel out, I'm going to write the pi at the bottom. So pi's cancel out. Now here, simplify. I have the negative side, have 360 over 8, technically, 360 over 8. I simplify a fraction, multiply a fraction, however you know how to simplify. I'm going to say, well, 360 and 8. Let me divide each by 8. Right, 360 divided by 8, what's that, 45? So my measurement here is negative 45 degrees. All right, let's take a look at number 39. It's given to us in degrees. So to begin with, I have negative 420 over 1, because I'm going to make it a fraction. The other thing I have to do 2 pi and 360. I don't want to get rid of pi's this time, so I'm going to put the 2 pi on the top and the 360 at the bottom. So I have the negative. On top, when I multiply 420 times 2, that gives me negative 840 pi over 360. Simplify your fraction as much as you can. I'm going to divide each by 10. So I have negative 84 pi over 36. Then I'm thinking, all right, what can I divide 84 and 36 by? What if I divide each by 4? So let me write down what I have here. Negative 84 pi over 36. All right, I'm dividing each by 4. I'm trying to simplify. So I have 21 pi over 9. Then I'm like, can I do any better? Yeah, let's divide by 3. So I'm going to have negative 7 pi over 3. And that's as low as I can go. Now, how am I going to type this? Negative 7 pi over 3. Lastly, let's take a look at question number 40. Negative 17 pi over 6. I'm going to multiply this to 360 over 2 pi. I want the pi's to cancel out. So I have a negative. I'm thinking the top, how much is 17 times 360? And I should get 6,120 over 12. Now, how much is 620 divided by 12? That's 510. So my answer is negative 510.